let's consider this diagram here. We're asked to find the length of BC, which is this length just here. Looking at the triangle DBC, we can see the only thing we know is the angle 28 degrees. So we don't have enough information in this triangle at the moment to work out the length of BC. However, if we consider DBA, we know this length and this length, which will enable us to work out the length of DB. I'm going to call that x for now. Once we've worked out the length of DB, we will have enough information in the triangle DBC in order to work out BC. To work out the length of DB, we're going to use Pythagoras' theorem. We should spot that we need to use this because we have all lengths involved: 20 meters, 16 meters, and the length we want to find. Let's just remind ourselves about Pythagoras' theorem. Here we have a right-angled triangle. This length, the hypotenuse, we'll call it A, and the two shorter sides we'll call B and C. Pythagoras' theorem states that A squared is equal to B squared plus C squared. If we look at the triangle we have, the hypotenuse is 20. So 20 squared is equal to 16 squared plus x squared. Just writing this in a different order, we have x squared plus 16 squared is equal to 20 squared. And if you look at this closely, you'll see that I've done nothing more than write it in a different order. Taking 16 squared from both sides gives x squared is 20 squared, take away 16 squared, and we can now calculate x squared is equal to 144, and taking the square root, x is then equal to 12 meters. This is an exact answer. So we now know that x is 12 meters. We want to find the length of BC, and I'm going to call that y. We know this is a right angle. Remember, we have 180 degrees on a straight line, and the angle to the left, the angle DBA, is 90 degrees, so it follows that DBC must also be 90 degrees. We know this angle here. This is the adjacent compared to that angle. The longest side is always the hypotenuse, and this side is the opposite. Writing down our mnemonic, knowing we have the adjacent and the opposite, we have so, car, toa, and for opposite and adjacent, O and A, we know it's the tangent. Working from the definition, the tangent of the angle, which we know here is 28 degrees, is equal to the opposite, which is 12, divided by the adjacent, which is y. We've seen this configuration before, and we know the net result of rearranging is that the y and the tan 28 swap positions. So y is going to be 12 divided by the tangent of 28 degrees. This calculates to give us 22.568, 7 and so on, which is 22 0.6 meters if we give the answer correct to 3 significant figures.